So our focus today is SQL or structured query language. The method is something like this. Not only we will cover basic concepts, we will be taking up hands-on practical also. The level which we are going to cover today is that of a business analyst or an IT business analyst when it comes to SQL. We will be covering the SQL in something like 2 full sessions, or if required, 1 more half session. So this Sunday for 2 hours we are spending on SQL. During the week I expect you practice a bit, and then we will move ahead with yet another set of concepts. So SQL is a standard programming language to communicate with databases. You utilize SQL to work with what are known as relational databases. You would have heard this word relational database management system or an RDBMS. Relational databases are very popular with business applications. So if you have a banking application, if you have a application which is basically managing insurance records or records for telecom subscribers, it is necessary that they at the back end for the database, they follow a database which has got a relational design. It could be from any company, could be from a standard company like Microsoft SQL Server or Oracle or IBM DB2. Within a database, what you do, you store data, you update data. Sometimes you say you retrieve data, you create new records, etc. So let's focus quickly what is an RDBMS system. An RDBMS system is a software. This software allows you to manage and maintain one or more databases within its system. And these databases follow what is known as a relational design. So we need to understand what is a relational design. In a relational design, data is kept in multiple tables. So say, for example, you may have I'm just taking a simple example of an employee management system, wherein you may have a department table where the department information is stored. You may have an employee table where employee information is stored. You may have a salary table where the salary for individual employees are stored. So, but then this department table, employee table, and salary table will be linked with each other via primary and foreign keys. Let us understand what are primary and foreign keys with an example, because this is the relational design. Only with the relational design, you will be able to appreciate this. See, there is this customer table. In the customer table, we have these 3 records and these 3 columns: customer ID, name, and email ID. As you may guess, that customer ID will be unique because we can't provide a duplicate customer ID. And not only it is unique, we will shortly learn that it is a primary key. So primary keys, basically a cell in a primary key will be unique and not null. So this is the customer table. One customer, say for example, John Doe, can make multiple orders. So the orders are being managed in the order table. So how are these 2 tables linked with each other? A customer ID, which is here, gets reflected here. So this one tells us that it is John Doe who has made this order ID 101. And number 2 tells that it is Jane Smith, which has basically made an order, which is order ID 102. In fact, in the customer ID column here, this column, for now, we cannot have any other customer ID except for 1, 2, or 3. Because you see, we do not have a customer ID 102 in the customer table. So this is what we call as the relational design. And this is what we call as referential integrity. Referential integrity will be breached. Let us say if we add one more record here, and wherein we provide, say, customer ID 102 or 103, because it will not make any sense because there is no such customer with customer ID 103. I hope this simple concept is clear to each of you. Just in case you have a doubt, just let me know, because it is this concept which will move us forward.
Yeah, I'm able to understand. Thank you.
Okay, thank you.
One question from my side on this.
Please, please.
How to decide which can be counted as the primary key? What would be the criteria to decide that? Take a decision on this.
So, say for example, normally IDs, say for example, a student ID, a customer ID, these are kept as primary keys, because you may have a person with duplicate names. It doesn't make sense. So normally we create something like an employee ID, a customer ID, a department ID, a unique ID which will be assigned, which will not repeat. That is kept as a primary key. That is good
Okay.
design. Otherwise, Oracle or SQL does not stop you to make name as a primary key. But then you may be a bit restricted. Let us say if there are two persons with the same name, then you will have to basically follow John Doe 1 and John Doe 2 and John Doe 3 in your customer table. Then it also means that John Doe 2 and John Doe 3, whenever they will receive their merchandise which they have ordered, they will always feel irritated that why have they appended 2 and 3 ahead of my name.
Right. Got it.
Okay.
Thank you.
So we move ahead. Let us understand some basic concepts, because it is these concepts which will take us forward. So there is a relational database management system, a system like Microsoft SQL Server, a system like MySQL software, a system like Oracle, the legendary RDBMS system. So this relational database management system will be installed on a what we call as a hardware device, and this hardware device is called as a database server. On this database server, we will have a typical OS or an operating system, and onto this operating system, RDBMS will be installed. Now this RDBMS can handle one or more databases. So we have to create the database within the RDBMS. We can have one, we can have two, we can have 20. That doesn't stop it as. So what is a database? A database is a collection of organized data that can be easily accessed, managed, and updated. In SQL, databases are used to store data in tables. Just understand the concept that within a database, there will be several database objects. A table is one such very important object. It is in this table that we are storing the information, something like this. So, say for example, if there is a system like Amazon e-commerce, maybe within a second in the order ID table, thousands and tens of thousands of orders are getting populated, or new records are getting inserted. Table. So tables are fundamental objects within a database. They consist of a row and column where each row represents a record. This is a record. One John Doe and John@example.com, for example, these are columns: customer ID, name, and email. Customer ID is what is known as the column header. These are the column headers. So this is how table design takes place. So fields, I have told you, columns, and records are rows. So we have columns and we have rows. Each row will basically tell you some detail. So say for example, in customer ID, we have 3 rows for now. There may be a customer table where you see tens and thousands of customers. Have a look at this data table. We need to understand. So say for example, this table has got ID, name, age, email, join date, salary, something like is active, and department ID. So say column, a vertical set of data in a table. So this is a column. Every column will have a column header. In fact, when you will work as a business analyst on a project, your application or your system may have something like, let us say if it is a big application and it is having some 500, 600 tables, even within these 500, 600 tables, there will be some 20, 30 tables which will be quite important. So as a business analyst, you need to understand the table structure of those tables and what is the information which is getting into those tables. Column header. Every column will be provided a relevant column header. It should make sense. Row. A horizontal set of data in a row is a single record of entry. Record. So record is basically one row. Now let us focus on data types. Each of these column headers, for efficiency and for data integrity, we provide some data types. So say for example, if our design is such, we will restrict that only numeric data be inserted in the ID. Whereas here in the name table, we may allow alphanumeric data. Again, in age data, let us say if we would like to handle the age in a manner that we would like to capture only years of age and not the month or anything beyond the decimal point, again, we can provide an integer and also a positive integer because you know age cannot be negative. Here we can have an alphanumeric restriction. So we can have numbers, we can have, alphabets. Date in itself is a data type. How dates are handled, because dates have got a certain format. For salary, we can have a currency, we can have, number of points after the data type. Then there are something called as a Boolean data type, 0 or 1, true or false. So say, for example, whether the customer is active or not. And then ID is again numeric. So please understand, a table will have rows, will have multiple columns. Columns have a column header, and the column header will have a data type. So all this is specified while we create the table. The table structure is basically prepared by the system analyst. But as a business analyst, you also need to be aware of the table structure of important tables in your application, and you also be aware of the data types. Okay.